We are now multiplying expressions involving square roots. If you recall, we have our multiplication property, and it says that if a and b are greater than or equal to 0, then we can say that the square root of a times the square root of b equals the square root of ab. So we can push together radicals when it comes to multiplication. We couldn't do that with addition. We could not say the square root of 2 plus the square root of 3 equals the square root of 5. We couldn't push together addition, but we can push together multiplication. So the square root of 2 times the square root of 3 equals the square root of 6. Now, when we were adding and subtracting radicals, what was our procedure? Well, first we simplified. Then we added or subtracted. Our procedure for multiplication is going to be the opposite. Our procedure for multiplying is going to be the opposite. We are going to multiply first. Then we're going to simplify. Now, if you were to simplify before you multiply, in the end, you'd have to simplify again, so you're going to do extra simplifying. We're going to assume all variables represent non-negative real numbers. The square root of 2 times the square root of 8. Well, we can push them together under one radical and say it's the square root of 2 times 8 or the square root of 16. And that's a perfect square, so we can say that's 4. If I had simplified first, I'd have the square root of 2 times, well, 8 is 4 times 2, so that's the square root of 4 times the square root of 2. So that's the square root of 2 times 2 square root of 2. And now I multiply and I get 2. And now I'm going to push together the two radicals and say it's the square root of 4. And hey, that's a 2. So we get 2 times 2, and that's 4. Look at all the work I did. If I multiply first, it's faster. Okay, the square root of 12 times the square root of 3. Again, push them together. And we get the square root of 36, and that's a perfect square. So we can take the square root, and we get 6. Here we have a negative times a positive, so the result is negative. And the square root of 5 times the square root of 20, well, 5 times 20 is 100. So that's negative, that stays out front, and the square root of 100 is 10. We have the square root of x cubed times the square root of x to the 5th. We're going to push them all together, and we're going to say it's the square root of x to the, well, 8th power. That's an even exponent, so this is a perfect square. So we get x to the 8 divided by 2, half it, and we get 4. This one looks nasty. We have a negative times a positive, so we're going to get a negative. They're all under radicals, so push them all together. Let's multiply the numbers first. 50 times 2 is 100. U cubed times u is u to the 4th power. V squared times v to the 4th power. Well, that's v to the 6th power. Well, 100's a perfect square. U to the 4th power is a perfect square, and v to the 6th is a perfect square. We could just take the square root. So we get 10. U to the half of 4 is 2. V to the half of 6 is 3. The square root of 5 squared. Well, that's the square root of 5 times the square root of 5. Push them together, and we get the square root of 25. And the square root of 25 is just 5. In general, the square root of 5 times the square root of 5 is 5. What effect is that negative going to have? Well, that's negative square root of 5 times negative square root of 5. So negative times a negative is positive, and the square root of 5 times the square root of 5 is 5. We have the square root of 3x squared, if we were to square the inside, we'd get the square root of 3 squared is 9, and of course x squared. They're both perfect squares. Square root of 9 is 3, and we get x to the, divide the exponent by 2, and we get 1. Basically what we have is the square root and the squaring are undoing each other here and here. Here it's the same basically, but that negative, well, whenever we square a negative, we wind up with a positive, and that's the only effect there. Okay, the square root of 3x times the square root of 3x, push it all together and we get the square root of 9. X times x is x squared. All perfect squares, so we get 3x. Well, the square root of 3x squared is just 3x. They undo each other. Or the square root of 3x times the square root of 3x is just 3x. So in general here, we can say that the square root of a squared equals a, and the square root of negative a squared also equals a. If that negative were not being squared in here, if it were in front of those parentheses, then we'd have a non-real number. We'd have an imaginary number. Okay, in addition, the square root of a squared is also equal to a. And the negative square root of a squared is also equal to a. So looking at this example, if we were to square this, we'd get 95 squared, whatever that number is, which is huge, x squared. And then we'd try to square root it. It's easier if we just look at this and say, hey, we're square rooting a square. We're going to get whatever's inside here. And we get 95x. Same thing here. If we were to square this, we'd get a trinomial, and we'd be stuck. But as it stands, we could say we're square rooting a square. We're going to get whatever's in here. And so we get x plus 6. Looking at this one, notice we cannot break it apart. We do not get to say that's the square root of x squared plus the square root of 36. We can't say that. We cannot break apart addition or subtraction. There's really nothing we can do with this. So this cannot be simplified. Okay, if you recall, if I wanted to multiply 2x times 3x, we would push together into the number part, so we'd say 2 times 3 is 6, and x times x is x squared. That's the same thing we're going to do here. We are going to push together the number part, so 2 times 3 is 6, and then we're going to push together the radicals. Well, the square root of 5 times the square root of 10 is the square root of 5 times 10, which is 50. Remember, we said we multiply first, then we simplify. There is a perfect square that goes into 50. So we're going to pull it apart. Perfect squares, whatever's left. 25 goes into 50 2 times. So we have 6 times, well, square root of 25 is 5, times the square root of 2. Pushing together the number part, we get 30 square root of 2. Well, what we're going to do is we're going to multiply the numerical values first. 5 times 2 is 10. Then we're going to multiply the variables out front. We have x times x, that's x squared. Then we're going to multiply our square roots. We're going to multiply these insides. 3 times 6 is 18. Y times y is y squared. Now we try to simplify our radical. We have 10x squared, and now we're going to put our perfect squares and whatever's left. Well, 9 goes into 18 twice. Y squared is a perfect square. So we have 10x squared times These are all perfect squares. We created it that way. Square root of 9 is 3, and we get y to the half of 2 power, which is 1, times the square root of 2. Now done, we can push together the 10 and the 3 and say that's 30 x squared y square root of 2. Okay, again, let's push together the number part, the numerical part, so we have 2 times 3 is 6. Let's push together these variables out front. X squared times x gives us x cubed. And now we're going to multiply our square roots, and we get the square root of 10x times 5. Well, that's 50x. Now we want to simplify our radical. Perfect squares, and whatever's left. Well, 25 goes into 50 2 times. We can't pull any x's into the perfect square radical, so we're going to put the x here. Only even powers of variables can go in our perfect squares. So we have 6x cubed times the square root of 25 is 5 times the square root of 2x. And now pushing together the 6 and the 3, we get 30 x cubed times the square root of 2x. So what did we do? We multiplied and then we simplified.